hope all of us are doing great. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. First, I would kind of like to request our members to allow me appreciate our incoming members, and thank you for the input that we have been having in our comment section. And I'd like to kindly appreciate our members and request them to be checking our discussion boxes for various uploads that we do. They're going to contain a number of links which are going to be particularly concerning videos similar to topics under discussion. Now, in this case, we are going to look at a section of some of the concepts we are going to come across in arranging or trying to write orbital diagrams and the electronic configuration of various elements. And these are going to assist us, of course, appreciate various designations that we're going to have for each of the elements for various, of course, representation for the electronic configuration. And that is basically going to be giving us an indication of elements, different physical and chemical characteristics. And in this case, as I said, we are going to witness a specific trend. And of course, we are going to see that some of the elements which are closer in the periodic table, perhaps across the various periods and down the various groups, are going to be exhibiting some either similar or different properties. And this, of course, in trying to understand the organization of these specific elements in terms of electronic configuration is going to provide for us a way of appreciating these specific elements. And that basically is going to be concerning their various applications in our day-to-day life and some of the unique characteristics which they are going to display in their chemical and physical properties. Now, in our last discussion, I had, of course, mentioned a few of these concepts of the periodic table, whereby we had basically discussed about the concept of the periodic table and given a specific, of course, arrangement which elements are going to assume. Particularly, I can just give it in terms of a rough block, and of course, we're going to just have it in this particular, in this specific sense. So I'm going to have this one perhaps indicated as such, and I'd say that this specific point, we're just going to have just a hypothetical illustration for that. So in this case, this particular section consisted of S block elements, and then we had the P block elements being represented at this far end of our left side of our right side, particularly of the periodic table. And the middle part, we had what we refer to as the D block elements. Now, in this case, I mentioned that basically we are going to have these D block elements given as such, but technically we're going to see that this is going to be a section of what we refer to as the transition elements, which are going to appear in between the S and P block elements. And there is a subsection of these transition elements, which we are going to refer to as the inner transition elements. And these are going to be, of course, the actinides and lanthanides series, which, of course, I've mentioned in one way or another in some of our discussion. Now, in this case, I looked at the periodic table and the periodic trends. And, of course, this is going to assist us in trying to appreciate the specific placement of various elements we're going to come across in the periodic table. Now, the concept of orbital diagrams and electronic configuration are going to assist us appreciate the arrangement of electrons in each of these specific elements. And of course, we're going to see that the concept of orbitals for the S, D, and perhaps we're going to look at the F block elements, which is going to be somehow an integral part of these D block elements. And of course, they are going to assist us appreciate how these periodic trends are going to be displaying different properties for the chemical and physical characteristics as I've mentioned. Now, in this case, I discussed the concept of course, periodic trends for the atomic number, ionization energy, and other concepts of electronegativity. And of course, these are going to be giving us, in a nutshell, the various characteristics of the chemical and physical properties. Now, in this case, I said that, of course, dividing the periodic table in these specific sections for the SD and B block and perhaps F block elements for these inner transition metals, they're going to give us a sense of characteristics for the most of the transition elements, which we said, of course, are going to fall under the category of metals, and these are going to be actually the alkali and alkaline earth metals. Now, this is going to consist of some of the elements of the non-metals, metalloids, and of course the rare earth, or rather what we call the noble gas or the noble elements, which of course are also going to display some characteristics which are going to be unique. In this case, of course, for the orbital diagrams, I'm going to start this one by trying to give just a few concepts which are going to assist us understand the basic structure which is going to be assumed by trying to have the orbital diagrams and the electronic configurations of various elements. Now that summary in a sense is going to provide for us a basis for having that. Now in this case, I'm going to look at three basic concepts. These are going to be energy levels, sublevels, and then lastly I will look at the concept of orbitals, which are going to form our three main objectives for understanding. Of course, they are not going to be comprehensive. We are going to do others in some of our videos, but these are going to form a basis for us in understanding a representation of our orbital diagrams and the electronic configuration. Now, the concept of our energy levels is going to be, of course, I've mentioned it in some of our videos, but this is going to be used in trying to indicate what we call the relative sizes and energies of the atomic orbitals. And as we had said, of course, these orbitals are going to be what we refer to as probabilities. Now, in this case, I mentioned this one under the concept of the Schrodinger's equation and its, of course, subsequent development. Now, this concept of orbitals, of course, as we had mentioned, are going to be probabilities or electron cloud. Now, in this case, these are going to assume various geometrical orientations, which are going to be giving us a range of orbitals or depending on their various geometries. Now, in this case, the concept of energy levels, as I've said, is going to indicate the size of this electron cloud and the particular energies of these electron clouds. Now, these are going to be represented using a whole number, which are going to range from number 1 to 7. And these are going to be given a designation of the letter N, as we're going to see later in our discussions. Now, the sublevels are going to be a division of what we call the energy levels, and they're going to be as well, of course, numbers of what we call as subdivisions of these specific energy levels. And of course, these are going to be equal to the value of N, which I've given in this particular case. But particularly, they are going to be designated using a specific, of course, a letter which is going to be given as L. Now, if you try to remember our discussion on the concept of quantum numbers, of course, which I'm going to put a link in the description box, these are going to be indicative of the various quantum numbers which we have discussed in some of our videos. Now, these sublevels are going to be given in terms of L. And of course, in order of increasing energy of these sublevels, they're going to be given as S, P, D, and F. And of course, these are going to be the equality sign, or the sign which I've used in between there is going to indicate which sublevel, of course, is going to have more energy than the other. Now, this implies that the S, of course, sublevel is going to be having the least energy, whereas the F sublevel is going to be having more energy. So basically, this is going to be a trend of increasing energy of these specific sublevels, which of course are going to be a division of the energy levels which I've mentioned. Now, in our ionization of the periodic type, of course, I'm going to indicate these specific, of course, initials or designations which I've given, and of course, try to remember that basically they're going to represent the energy levels, sublevels, and of course, the concept of lastly what we're going to refer to as orbitals, which I've basically defined in a summary form in this case. Now, these sublevels can be described in various forms, and of course, they are going to consist of a number of orbitals, which you are going to see in this specific summary form, which I'm going to put on the board. Now, the S sublevel is going to contain only one orbital, and of course, this is going to be perhaps given in this particular order. So this is going to contain one orbital. The P sublevel is going to consist of 3 orbitals, and the D sublevel is going to consist of 5 orbitals, where the F sublevel is going to consist of 7 orbitals. Now, there are various rules which are mentioned, which are going to be accompanying the arrangement of electrons in these different orbitals which have been given in these specific forms of sublevels. And of course, there are specific rules which I'm going to mention perhaps in a different videos, which are going to be the Hans rule. I've mentioned the concept of the Hans rule, the Aufbau's principle, which is the build-up principle. And then I've mentioned about the concept of what we refer to as Pauli's exclusion principle, which are going to assist us particularly in trying to arrange these various electrons in different orbitals given as such. But in a summary form, I can mention that each of these orbitals is going to contain a maximum or have a maximum of 2 electrons, and that in a sense is going to assist us have different arrangements for various electrons and different orbitals. And of course, that is going to be in a summary form assist us try to arrange orbitals in various of course, electrons in various orbitals and have a general representation for electronic configuration of various elements in the periodic table. Now, in this case, of course, I presume that we have understood the concept of energy levels, sublevels, and orbitals. Now, in our next discussion, we're going to look at the subsequent concepts also, which are going to assist us build up on this particular discussion that we have done. And that, of course, is going to be assisting us generally in trying to understand the arrangement of electrons, of course, in various orbitals and the representations of electron configuration of various elements. So kindly check our description boxes, as I said, for various links of other similar videos. And also kindly subscribe and engage us in the comment section so that we can have a healthy discussion on this particular topic. So that is it for now, guys. Bye, God bless you. Catch us in our next video.